and it's very hot outside, and it's after lunch, so I'm gonna try to be loud as much as I can. I'm a loud person by nature. That's the teacher side of me, but please, if you can't hear me all the way in the back, let me know, all right? So are we ready to talk about smart grid reliability? First of all, what's smart grid reliability? What is it about? Do we really need to talk about it? I know there are many engineers right here. I see some green shirts, but I'm not an engineer. I'm a data person. I call myself a data artist or data analyst or data scientist, right? So I'm not an engineer. But what is smart grid reliability is about in simple words? I'm a simple person, like things to be in simple words. It's about what? It's the ability of the electric power network to deliver electricity to customers without any degradation or failure, right? And when we talk about degradations, we're talking power quality. You know, these are the power quality guys. Here, the focus of this project or this presentation is not on power quality. We're going to mainly talk about power failure. So, do you think we need to talk about smart grid reliability? What do you think? What's going on within the utility industry right now? What is happening within the energy domain? We are moving, for example, from the one-way power flow, right, within the electric circuits to the two-way power flow. We're adding all those new components to the grid, all the renewables, solar systems. We're adding the electric vehicle charging stations. We're adding the battery storage. We're adding switches. We're adding sensors, right? We're adding too many things to the grid. Right? So it's a big change. It's kind of a revolution. It's what we call paradigm shift. Have you ever heard that a revolution usually go well with reliability, or reliability goes well with a revolution? Normally, it doesn't, right? So we need to talk about it. According to some facts, like for example, some research that was done by Lacomar and al. In 2004, they say they made an estimate of the economic cost of power outage only within United States, and they say it's about what? $74 billion annually. And I think they updated that number in 2015 to something more than $100 billion. So we really need to talk. It's a significant topic, and research, as well as, of course, there are many challenges within this domain. So the objective of this project is the grid reliability mainly through data analytics. But it's not just any data. We're going to talk about what we call geospatial data or location data. We're going to talk about GIS system. How many heard of a GIS? What is GIS is about? You know, some people think of GIS as what? It's a tool that may help us make maps, right? Is that true? Is that it? Is that what GIS is about? It's an information system with all the components of an information system, and that system processes data, but not just any type of data. It processes geospatial data. So about it, GIS has been applied really extensively within public work and public health. It's been applied by utility industry. So for example, good example is Southern California Edison Dream Map and PG&E map, all those new maps that they got published, right? And they show us all those circuit data. These are example of how GIS has been applied in the industry. However, GIS has been mainly applied more as a display tool. For example, that Dream Map, it's a tool that helps company, utility firm, communicate to the developer where are the areas where we have good, where it's a good area for the development of, for adoption of DER, where are the areas where we might have issues with capacity constraints. So mainly these kind of map, it's a way to communicate to customers or to developer some type of data. But mostly utility companies are using different systems and different tools to do most of the analysis outside. Like, for example, we're doing, some companies are relying on Cooper Power, for example, software to do all the ICA analysis, and they just display the ICA, integrated capacity analysis, on those DRIM maps. GIS could do more than that. It could be, it's a beautiful tool that you can use to do data analytics. It can help you in all type of research. It can help you with descriptive type of research, predictive, and as well it offers you the platform where you can develop beautiful tools that can help you for decision support. And that's what I would like to show you today. So this research is mainly concerned with the smart grid reliability, but mainly on the distribution side. And of course, we know the difference between what's going on the distribution side. The transmission side is more of the high voltage network, right? Distribution network is the low voltage network, correct? A power outage on the transmission side, sorry, would cause, it has a bigger impact. However, normally you would have, in terms of the power outage count, you will get more. So 90% of the power outage that is happening is more on the distribution side, and that's the focus of this specific project. When I first started this research, I had two main questions. First one was about the current knowledge that existed already within that area, and that's the academic part or the theoretical part. So I went through all the previous literature, learning about what tools have been previously used, what kind of research has been done in this area. What have researcher methods have been used by researchers to address the smart grid reliability. I'm not gonna be talking much about this part because again, it's more of a theoretical part. But the output of this first piece of research was a new framework for energy informatics research and a new framework for the grid reliability research, and these are published. I could discuss them at the end, but if you would like to read more about it, it's in the Energy Informatics Springer Conference Journal, and you can look it up under my name and Dr. Brian Hilton's name from Claremont Graduate. The second question, which is the focus of this presentation, is how may location analytics can help you understand power outages and use to improve the reliability of the grid. So again, I did a broad automated research looking into different, I looked into Web of Science database, and I looked into IEEE database, and I read all the reports that have been published by the utility companies about power outages, and I came up with this framework, which kind of, we can call it, it's a typology or taxonomy of the causes of power failures. And it grouped power failures or power outage under three main buckets. First one, hardware and technical failures. And the second bucket is the environmental related failures. Third bucket is the operational related failures. And under that, of course, all the human errors, cyber security attacks, and all of that. One thing I want to mention, you know, why some of you would ask, why do we do that? We do that because it's a phenomena. Power outage is kind of a phenomena, so we need to understand everything about this phenomena. What's causing it? What kind of variable we're dealing with? So this was an EPRI project, a project that I worked on with the Electric Power Research Institute. So I got data, internal data, utility data, from a utility company, one of EPRI's clients. I got all type of snapshot of all types of data. So I got OMS, DMS data, I got AMI data, I got SCADA data, JETs, you know, just a little piece of every system. The first step for me was really trying to understand all this data and trying to come up with a model to relate this data and put it in some type of format so that it can be useful to help me predict and, you know, prescribe something. Also, I used external data. So the study area that I was working on was in Georgia State. So I relied on public available weather data, for example, those in the Georgia Spatial Data Infrastructure and GIS clearinghouse. And it gives you data, temperature data, and precipitation data, for example, and contours or lines. So what I needed to do, and I'm going to show you how I did that, I did actually needed to spatial join all the outage events, everything that have available on the map and for the on the distribution side to these. I had to relate them to this weather data. Also, I got some data from NOAA sites with all the storm details files. So I went through 7 long steps, and I'm not gonna, you know, talk about it in details, but I'm gonna highlight the main things. If you're working with utility data, you're working with big data, large, huge files. So first step that you really need to think about is how you improve performance time, how you're gonna the first thing that you need to do is to define a study area. You need to create a geodatabase so that you're kind of, so that you don't spend 2 nights running an operation or a process. Second important mention is that you need to use one common projection system, and of course I use the WGS 1984 to be able to use ArcGIS tools. Kind of the key things. You have to go through data cleaning and data preparation. And I'm serious, to understand the data and clean it and work with it, it took me around 3 months because, first of all, utility companies, they have an issue with data quality. So you need to set what is acceptable, what is not acceptable. What do you consider good data and what is bad data? To also define, deal with missing data. For example, management data, right? Tools data. You have missing transformer age data. What you're gonna do? Are you gonna pull an age of a pole, the closest pole to that transformer, and use it as a proxy, for example, to substitute for that missing data, or you're gonna replace the missing data? What you're gonna do about it? And I think it's very critical, especially at the time being. And I think this should, you know, utility companies each other need to define parameters, because later those parameters should, you know, will help you. We're all being, for example, measured against the same metrics, right? So we need to use the same parameters in order to those data be able to get. I'm gonna. One important thing I have done is that I've tried to group my outage data so that I can. So I put them. I created event category of power outage data, and that include everything under wind and simple line, tree group lines, any outage that had to do with a tree. You know, weather related as an equipment failure, system overload. Ask, why did you do it that way? No, no reason except that I say that's, data science is not just science, it's an art, right? So there is no reason for an artist to draw a line that way or this way, right? What artist, that's how I decide to look at, put in that type of category. Some tool in ArcGIS to explore the data initially. So for example, here's neighbor tool. I was interested in looking at the distance between events. Was that interesting? And that was interesting enough. So for example, if you look at the system overload event, you will find that the average distance between events kind of large compared if you look at the events that are caused by storm or weather. Interesting things. I use Model Builder to create 3 models to spatially join all my weather data to the outage data. And the thing is that a tool that could help you. It's basically a tool that can help you create workflows that sequence together a string of it was awesome because I was not going to go through all the 48. You need to spatialize the weather data with the outage, not just based on location and time. So our map model made it really easy and efficient. Again, I went through many joins and merge. I left the details slide. But Geodatabase that you create is really a relational, and you're trying to relate all apps. For example, asset management map with all the data. You try to relate it with the weather data, with the infrastructure data, right? Some exploration and correlation analysis, just understand what kind of the significant have or what kind of relation or correlations that I might have in my data. Optimized hotspot analysis in ArcGIS, which is a beautiful tool. It's an ArcGIS spatial toolbox that can help you identify the statistically significant clusters of, for example, outage, the area where location has a hotspot, right? The thing is that you can run this analysis in 2 ways. You can run it with an analysis tool, and you can run it without using the analysis. And you can run it without using. And kind of search question you're asking. So if you are if you run the optimized hotspot analysis without using an analysis tool, it's going to look at the power outage count, the power outage events count, and it's going to use the count as the values to be analyzed. But if you run it with the analysis field, for example, you used pole age or transformer age in the analysis sphere, you're going to be looking at a totally different thing. You're going to be looking at the outage, the power outage events that are associated with aging infrastructure or aging to it. Again, it all depends on what are you asking, what you look at. In addition to analysis tool, I use analysis. It can trends in cluster, not just look hotspot or statistically significant clusters or areas where infrastructure or where you have outage because of a certain cause. We're going to be looking at trends in different type of spots. There is oscillating spot. So for example, so you're not only looking at a significant cluster because of location, you're looking at location at time. And a location could be a hotspot only at a certain time of the year because of weather, for example. This tool is very helpful in doing that. Of course, you have 2 steps. analysis, you need to create the space-time by aggregating points, and then you run the. This is a spatial analysis framework that I came up with to look at the data. And as you can see, you go from level 1, it's more aggregate. You're looking at all the outage events. And then you start looking at each type separate, and then you start studying, other things that might associate with those outage events, like infrastructure age, or temperature, or trees pruning time, right? So let's look at the result of the analysis, and that's what I think will show you the value of this work. So, for example, this was something that I found when I first started exploring this data. So you can see from this just pie chart, for example, failed in service, power outage events, or events that are caused by equipment that is failed in service, has the highest reported outage event % count by cause. You can see that storm in that specific location in Georgia State is causing the highest reported power outage duration by cause. Initial observations that I had about the data was, again, quality of data is a big issue. So I was dealing with many missing data, many null fields, asset equipment age was mainly missing. So for example, I had data for switches. I had 4,600 records for switches, or for switches that are on my study area. I only had age data for 2% of this data. Like 100 records when only showed the date it was installed or the age for this. So I had to make decisions. I had to use a proxy, for example, in order to estimate, those data that I do not have. This is just the descriptive from SPSS. So of course, again, I was looking at those variables. And if you're running for continuous variables, you go look at the mean, standard deviation, min and max. For discrete data or categorical data, you need to look at frequency and %. This is the output, the results of the correlation analysis. And it was kind of interesting. Of course, some of you might say, oh, if you come up with some interesting correlation, maybe you can come up with a predictive model, correct? I am going to discuss that at the end and tell you what I found. But I saw there were some significant positive correlation, for example, between the outage event duration and the storm event. Also, I saw some negative significant correlation, like between the customer calls and the forestry management. These were interesting. This is ArcGIS. Average nearest neighbor analysis. The observed mean distance is kind of high if you're looking at system overload type of outage events. So the average observed mean distance was 171 meters, looking at those weather-related outage events, and it was 727 meters looking at those system overload outage events. It's kind of interesting observation. Output of the level 1 analysis, the optimized hotspot analysis, and again, I ran this without putting anything in the analysis field, and it shows you, where is your it used the Geodatabase or for every feature in this value. Really interesting, but not as interesting as an outage event that is surrounded by other events that is close to it. That's what makes a statistically significant cluster appear or hotspot. So when we run that analysis right away, where statistically significant, not just based on market. Look at the outage events by type. So weather-related events, for example, where would you see the hotspot or the statistically significant clusters in that area versus the tree events versus failure events in another area? Do you think this information would be helpful at all? Would it benefit a utility firm? Definitely it will. I need to know where are my problem areas, where are my weak areas, right? So that I can do what? I can plan accordingly, adjust my budget, do all of that. Here, that's the level 3, where you would be looking at, for example, the related outage that is associated with a certain temperature, right? Where are your hotspots, right? Where are your problem area? If you know that there is going to be a wave and you need to send people to inspect or crews to plan, to put them on standby, where should I send them, right? Where do I need to make priorities? Which part of the network? This kind of information, utility companies used to rely on old-timers knowledge, on what we call the tacit knowledge of people. But this has been changing. A lot of things is changing right now within the utility space. System that can help us scientifically find those areas. I'm not going to go through all the maps, but I would want to go to this one. That's the emerging hotspot. And again, the emerging hotspot analysis tool within ArcGIS, it's a beautiful tool that can help you identify trends. So you're not only looking at clusters based on location, you're looking at statistically significant clusters based on location at time. So you're not just getting one or two types of spots. Remember, in the optimized hotspots, we either get a hot spot or a cold spot, right? Here, we have all the both different colors. So we have, for example, the intensifying hotspot. We have the new spots that is starting to appear. New, that means it's been there for, maybe it was not before, right? Persistent, diminishing, sporadic, oscillating hotspot. Each one of them has a certain definition. Would that be helpful? Again, if you have a budget that I need to allocate, right? I need to understand what are my problem areas. Maybe I need to tackle this this area in the middle, that red, the intensifying, because I know this is the problematic area. That's where I have problems all days of the years, not just when a storm is hitting, right? But maybe I want to know also about the other location, right? So that I can make priorities. Whenever I have additional budget, I can tackle it. Again, so all those maps, I guess the slides are going to be made available. So this is the results of the analysis. And that's our simple, really kind of observation. Easily get from the maps. You can see, for example, that the tree-related outage for that specific, I was looking at outage from year 2013 to 2015. And again, it's a utility company in Georgia State. So tree-related outage had the highest number of location with hot trends, showed 259 total count of locations. These include the 40 consecutive locations with a single uninterrupted run of statistically significant hotspot. And the utility company, of course, can use this information to reduce the risk of wildfire, right? And keep customers safe, right? They can know the priority where there are. So, for example, I know President Pedro Pizarro of Edison was saying, well, we have 900,000 trees in our surface territory, right? We can only cut, or we have budget to cut 400,000 of those 900,000, right? We can cut them all, but do our customer willing to pay to cut them all? So what do we need to cut? This give you some insights on where you need to make priorities, better decisions, of course, to get more benefit out of the allocated budget. Weather-related outage, 160 locations with hot trends. Considering the availability of weather forecast, of course, the analysis can help utility prepare if a storm is expected. Equipment failure, 129 locations, system overload, 27 count. Again, data analysis is great, but not without impact, correct? So I wanted to show how this analysis could be useful. What I did basically is I did some type of what we call an instantiation. I instantiated that analysis framework that I created to show how it could be used. How can we develop a tool, for example, to help utilities in decision making? So I created 3 scenarios, case studies. One was a storm scenario. The weather service issued a red flag warning. And of course, the challenge in this case for a utility firm is where they could proposition workers and equipment in preparation of a storm. Second challenge was a vegetation scenario. So the grid has too many poles and wires causing problems. We need to know where should be the priority location. Challenge aging infrastructure scenario, and of course the goal was to define where should we reduce risk or inspect the infrastructure. So just bear. So I created a worksheet, and I'm gonna just give me a minute. I'm gonna hopefully try to get into it. Where is here? Oh, there is no internet. Very nice. All right. That's okay. I can just explain it, and then later on, if you need to look at it, or if you would like to have access to it, please let me know. So I created 3 worksheets in ArcGIS Insights, which is a great tool that can help you work with charts and maps at the same time, can show you different things. I created, for each worksheet, I developed multiple pages, each page just mainly to answer a certain question for a utility firm. So for example, a utility company would like to know where they should stage their workers because a storm is coming. Considering a certain type of storm that is coming, they could just go utilizing this. So this tool could be helpful to help utilities with their decision support. Of course, this is not a commercial product yet, and I had no intention to make it at that point of time a commercial product, but I know companies like ESRI, along with EPRI, the Electric Power Research Institute, they are working on it to make it available and to make a commercial tool out of it. Of course, the idea is to connect virtually any type of streaming data feed and transform the GIS application into frontline decision application showing power outage incidents and they occur. So one thing I'm also looking at right now is Arc Event processor, the Event server, where you can connect it to web server to get multiple data feeds and process that data, and of course link that to a decision support system where it could answer questions. Also, another future work is 3D images, and how you can incorporate 3D images within the GIS system, because you can really, the ArcGIS is a beautiful platform that you can use as database management. 3D images, sensors data, all of that coming from should be, if added into the ArcGIS Geodatabase that you're having, and you could do a lot with it. ArcGIS Pro is also something new that is coming out, where you could work with 3D images, which is something that I hope to build. So GIS offer a solution to analyze the electric grid distribution system. That's my conclusion for this presentation. Thank you for being here, and please questions. Yes.
So your models wasn't using any type of topography layer, no digital model, anything like that?
It was using simply data, raster data, and vector data, both of them. Again, it's mainly a relational model. All right, that's it. Any more questions? Yes, mainly to clean the data at the beginning.